video, we are going to look at how to find the missing length of a right-angled triangle using Pythagoras' theorem. And this can only be used for right-angled triangles, and we must have the length of two of the sides so that we can find the third side. Okay, so we know this is a right-angled triangle because we've got this sign here. This is telling us it's a right angled triangle. When we're doing any other angle, we put a curve to it. So that's our sign that it's a right angled triangle. And what Pythagoras discovered was that if we took the two shorter sides and we squared them and added them together, they would be the same area as the square of the longer side. That's a lot to take in. So let's have a look at this. Now, what his theorem was a squared plus b squared equals c squared. And so the two shorter sides would be a and b, and it doesn't matter which way round you write them. So let's say that was a and that was b. But the C must be this longer side. And I've just put in the corner here hypotenuse. The hypotenuse is always that longest side, so the diagonal side. And we can just abbreviate it to HYP. Okay, so let's work this out. We can say that A squared, so that would be 3 squared plus 4 squared equals c squared. So 3 times 3, or 3 squared, is 9. And then we're going to add to that 4 squared, which is 16. And that is going to equal c squared. Let's add these together, and that gives us 25. So 25 is c squared. And hopefully you'll recognise 25 is a square number. So if we want the square root of 25, that will tell us what c is. And of course, the square root of 25 is 5. So we can write in here that c would be 5 centimetres long. Okay, now that came out very nicely. And we call this the Pythagorean triple because it just comes out so nicely. 3 squared plus 4 squared equals 5 squared. Of course, we could get all sorts of numbers, all sorts of lengths. So we've got to be able to deal with it however it comes. Okay, before we move on, I'm just going to show you a demonstration. So Pythagoras was an ancient Greek mathematician, and what he realized, which is quite incredible, is that if you made a square using the two smaller sides of a triangle, then added them together, they would be the same area as the square of the longer side. So that's just a little bit of background, but why don't we go on and see if we can solve a few problems? And what I'd like you to do is pause the video if you feel confident, but only when you're ready, otherwise just stick with me. Okay, so here's our first one, and this one looks like the one we've just done, but let's work through it. So what we could say, what we've got here is we've got 3 and 4 are the shorter sides, and so if we square those, we will get the square of x. So I'm going to start by writing x squared is going to be equal to 3 squared plus 4 squared. And then I'm going to say that means that x would equal the square root of both of those. And I think this is a good way to write it because as we get into more tricky ones, we're going to be using our calculator. So we can, once we get to this step, we can put that into our calculator. Okay, well, should we do that now, even though we know what the answer is from our last example? So we can use the calculator. We're going to click on the square root sign and then put 3 squared, and we're going to add to that 4 squared, and we click equals, and we get an answer of 5, which is good because it agrees with our last calculation. So equals 5 centimetres. And that's the first one. Okay, let's have a look at number 2. And if you feel confident, pause the video and have a go yourself. Right, so we're going to start by saying x squared is equal to 5 squared plus 12 squared. So that means that x is going to equal the square root of 5 squared plus 12 squared. Just to be clear, if we square something, then if we want to do the opposite or the inverse, we have to do square root. Okay, let's find our calculator again. I might have to move this around a bit. Here we go. Let's set it to on, and then we're going to type in the square root of 5 squared plus 12 squared, push equals, and we get an answer of 13. So again, this one is also called Pythagorean triple because it comes out so neatly. Right, so that's 1 and 2 done. Let's move on and look for question 3. Okay, pause the video and have a go yourself if you feel confident. Stick with me if you don't. Right, so we've got, I'm going to set it out the same way, x squared equals 5 squared plus 6 squared. And of course, it doesn't matter which way round you write these two. So x is going to equal the square root of 5 squared plus 6 squared. Let's grab the calculator and type it in. Square root of 5 squared plus 6 squared equals, and what it's done now is it's given the answer as square root of 61. We want to change that to a decimal, so we use this button here. Okay, if we click on that button, it's going to change it to a decimal. And what we're going to do for these is do it to 1 decimal place. So we've got 7.8102. So if we want to cut it off at 1 decimal place, that is going to give us an answer of 7.8. So 7.8 centimetres to 1 decimal place. Okay. Right, let's try the next one, question 4. So we start, and pause the video if you want to. X squared is equal to 4.6 squared plus 9.8 squared. So x is going to equal the square root of 4.6 squared plus 9.8 squared. Let's bring our calculator back. All clear. And then we're going to do square root of 4.6 squared plus 9.8 squared. and that equals, and this time it's giving us a decimal straight away. We're going to to one decimal place, so that's 10.8 centimetres. X equals 10.8 centimetres. Great, we've got two more to do, and these two are slightly more difficult, but never fear, there's always a way. Okay, so what's different here is that we've been given the longest side, the hypotenuse. We have to find one of the shorter sides. So we've just got to be a bit more careful when we set up our equation. So remember what the rule was. It's going to be that x squared plus 9 squared equals 11 squared. Let's just check that. The two shorter sides added together with each one being squared is equal to the longer side squared. So that is going to be our starting point. So we've just got one extra step to do. We want x to find out what x is. So we need to rewrite this x squared, and we're going to take the 9 squared away. So we want to lose it from this side, but if we want to take that 9 squared away from that side, of course we've got to take it away from this side too. So that's one way of looking at it. So it'll become 11 squared minus 9 squared. Or you can think of it as if these two added together make that, then that minus one of those is going to take us back to the other. Food for thought, you can have a think about that. Okay, so now we're almost there. X is going to equal the square root of 11 squared minus 9 squared. So just be careful with these signs. Let's get the calculator back. So square root of 11 squared minus 9 squared equals, and again it's given to us with a square root, so we are going to change it to a decimal with this button, and we get 6.324555532. We're going to do it to one decimal place, so that is going to give us x equals, should have written it down before I moved it, 6.3. And that's meters, and that's to one decimal place. Okay, last one, and then you can do plenty more practice if you need to. Right, so again, we've got to find one of the shorter sides. We've got the longest side, so we're going to do the same thing as above. We're going to say x squared plus 11 squared, so our two shorter sides equal our longest side squared. So again, we've got to move it around. So we get x squared is equal to 23.8 squared minus 11 squared. And finally, that means that x is going to be the square root of 23.8 squared minus 11 squared. Right, go to our calculator. Square root of 23.8 squared minus 11 squared equals, and there we get a square root sign. So let's click on SD and we get decimal, and it says 21.10544953 to one decimal place. That will be 21.1. Put that in, equals 21.1, just about squeeze in centimetres. And that's the end of this video. I hope that's been helpful.